The other thing you should know about solving quadratics is how many solutions each one has. So if you look at a graph, like this graph, because the vertex is on the x-axis, there's only one solution to this graph. In an equation, what that means is that when you get the squared part all by itself and you take the square root of both sides, it's equal to 0. And normally we have positive and negative versions of the square root. But if it's equal to 0, plus and minus 0 are the same number. They're both 0. You can also have no solutions. So this first example is if you have one solution. You can have no solutions. That would mean that your vertex is above the x-axis and your parabola is pointing up, or your vertex is below the x-axis and your parabola is pointing down, so it would never cross the x-axis. In an equation, what that looks like is when you get the x squared part by itself, it's equal to a negative number, and since we can't take the square root of a negative number, there is no answer. The final version is you could have two solutions. This is what most commonly happens is you have two solutions, and what it looks like algebraically, and you can see the two solutions because graphically it's crossing the x-axis in two different places, and algebraically what that would look like is x squared equals some positive number, because then if you take the square root of both sides, you would have the positive square root of 3 and the negative square root of 3, so there would be two solutions. So I don't have an example problem for you to do on this one, but I just wanted to remind you about the possibility of having either one solution where your vertex is on the x-axis, no solutions where your vertex is above the x-axis and it's pointing up, or below the x-axis and it's pointing down, or two solutions where your vertex is below the x-axis and then crosses in two different places, or above the x-axis and upside down and crosses in two different places. So that is the number of solutions for a quadratic.